Our fourth presenter is a student in biology. Biology is very well represented today. Yeah, a lot of biology to learn today. This particular student is also connected with the Annis Water Resource Institute. Our fourth presenter is Tyler Harman. Please welcome Tyler.
When we think of coral reefs, most people think of a tropical, pristine marine ecosystem that's teeming with life. However, with the introduction of greenhouse gases caused by human activity, that impacts climate change, and it further exacerbates issues related to coral reefs, such as bleaching and disease. High temperatures can impact corals by expelling their symbiotic algae, which they rely heavily on, as those algae provide them with food. In addition, those high temperatures can impact corals by decreasing their overall immunity and having pathogenic bacteria infect them more easily. It's a terrible situation for tropical coral reefs all over the world. But what about temperate reefs? Studies are starting to show that thermal stress events are making its way up to higher latitudes, and even disease being a potential threat in the future. However, no one necessarily knows exactly how temperate corals are going to be impacted in the future, and they could see the same fate as their tropical counterparts. This is where my thesis research comes in, as I was really interested in further understanding if these corals have a particular resilience to thermal stress and disease, or if they're going to see the same fate. So I did this by analyzing a temperate coral species called Strangiapaculata just off the east coast of the United States. So this summer, I went out to Rhode Island and did some diving and brought back coral colonies to the Annis Water Resource Institute, where I began my thermal stress experiments. Now we're still in the process of analyzing all of the data, but one of the things that I measured is something called reactive oxygen species. Now, this is a normal function, or a byproduct of normal cellular function, but in the event of thermal stress, these increase in concentration and can become rather toxic. By utilizing an image flow cytometer, we can actually detect whether the fluorescence of ROS is higher or is greater in thermal stress environments or not. And looking at our data, we actually see that less ROS is actually being generated in this coral species particularly. It has huge implications of being a thermally tolerant coral species. While we still have the immunity data to still go through and compare with our ROS data, this has huge implications for the further scientific research of coral physiology, and we can integrate these findings into management practices to further better our coral reefs in the future of climate change. Thank you.